Number 5 on the 2021 exam. This is a differential equation problem mixed with a Taylor polynomial, actually. Let's see what it says. Let f of x, y equals f of x be the particular solution to the differential equation dy dx equals y times x ln x with initial condition f of 1 is equal to 4. It can be shown that f double prime of 1 equals 4. Part A, write the second degree Taylor polynomial for f about x is equal to 1. Use the Taylor polynomial to approximate f of 2. Okay, so let's remember the formula for the Taylor series to get the Taylor polynomial. We stop at the second degree term, or the x squared term, or in this case, the x minus 1, parentheses, squared term. That's the second degree term. Okay, so t2 of x is f of 1 times x minus 1 to the 0, which is 1, over 0 factorial, sorry, which is also 1, so I only wrote f of 1, plus, next term, f prime of 1 times x minus 1 to the first power, all over 1 factorial, plus f double prime of 1, x minus 1 squared, over 2 factorial, which is 2. Okay, what's f of 1? That's 4. What's f prime of 1? Well, we need to find that. F prime of 1 is, since y is f of x, this is f prime right there. Okay, so dy dx evaluate at x is equal to 1 is, well, what's y of 1? 4. Yeah, times x, which is 1, times ln of 1. ln 1 is just 0, so it's 0. Okay, so this term goes away. And f double prime of 1 is 4. 4 divided by 2 is 2. Technically, you don't need to simplify, but I did. So 4 plus 2 times x minus 1 squared. That's part of part A, the first half of part A. We're going to use this to approximate f of 2. So we just want t2 of 2. t2 of 2 is 6 if we plug in x is equal to 2. Okay. Part B, use Euler's method starting at x is equal to 1 with two steps of equal size to approximate f of 2. Show the work that leads to your answer. Okay, so we're starting from x is equal to 1, so f of 1 is 4. Yeah? And then we want to go 2 steps to 2. So 2 minus 1 divided by 2. So 2 minus 1 divided by 2, that's 1 over 2, which is half. So the step size is half. Okay? So the next one would be f of 1.5, because we're doing a step size of half. Okay? So it's approximately equal to the previous guy, f of 1, plus f prime of 1 times the step size. Okay? So what's f of 1? That's 4. By the way, you should write approximately equal to, not equals, like up there, but approximately equal to. Okay? Sometimes they are picky on the scoring guidelines, and they take off if you don't write approximate. And if you write equal, it's a different interpretation, so they could mark you off. I've seen it before in some scoring guidelines, okay? So be sure to write approximately equal to. After that, you can say this is equal to, that's fine, but this is how I chose to write it. So f of 1.5 is this guy, as I was saying, approximately equal to this guy, as I was saying. So f of 1 is 4. F prime of 1, we found that here to be 0 times 0.5, which is 0. So f of 1.5 is approximately equal to 4. And then we move on to the next step. F of 2 is take the previous point, f of 1.5 plus f prime of 1.5 times 0.5. Okay? So this is, we found to be approximately 4. What's f prime of 1.5? So we got to go here now. This is f prime. So what's y of 1.5? We found that approximately here, right? 4 times 1.5 times ln 1.5, and don't forget a times 0.5 still, okay? So technically you can just box this as your answer. I chose to simplify a little bit, so I chose to simplify it to 4 plus 3 ln of 1.5, and that boxed my answer. This should be acceptable, so I would actually box it there if I were you. Okay? And then part C, find the particular solution to the differential equation with the initial condition f of 1 is equal to 4. So we can just use separation of variables here, move all the terms with y on one side, move all the terms with x on the other. That's what I did there. Okay, integrate both sides. This is just natural log y, an absolute value. This is integration by parts. Yeah, this is a very standard integration by parts problem, so hopefully you recognize that. So I do integration by parts. That's right here. Don't forget the plus c. Now from here, I would just plug in the initial condition right away. F of 1 is equal to 4. So y is 4, x is 1. Right here. Okay? You solve for c. c is equal to ln 4 plus a 4, because this guy would go away. ln 1 is 0. Okay? So plug this as your c. right there, and then just exponentiate both sides to get y is equal to this guy. This is all in the exponent. Okay, so either put parentheses there or just write it really carefully like that. Okay, and then don't bother simplifying anymore. Box your answer there. Okay, it's because you have to write it like this because it's y equals something. You can't write it like this. You won't get the full credit. You have to write it like that. Y equals something. Okay. All right, that's it for this video. Pretty standard in my opinion. Hopefully this was good practice if you are studying for the AP exam. Please give this video a like if it was helpful in any way, and hopefully I'll see you in another video as well. Bye.